Hey everyone, my name is Steven Tonthat and this year's chassis lead with Viking Motorsports. With COVID-19 and the shift to working from home, I just want to share a few things about what Viking Motorsports does and a few of our developments going to the 2020-2021 competition year. So who are we? Viking Motorsports is a PSU student-run and FSAE recognized organization, committed to building race cars from the ground up. Our cars go through a rigorous process which includes design, manufacturing, and testing before we bring the car to yearly competitions hosted by FSAE. Scrutineers and design judges inspect the cars and assign points before they are raced against the clock. All of our work leads up to the competition, and sponsor companies often offer job opportunities to students on the spot. When we aren't getting ready for competition, we send our cars on track days, play Jackbox, and share our interest and knowledge on engineering and cars. This year, we are continuing work on our electric car, which we plan to race in 2021. In the past few months, COVID-19 has changed the way people around the world interact with each other, and Viking Motorsports is no different. We have adopted methods to continue doing work from our living rooms, which include using remote desktop, modeling software, and voice over internet software to conduct meetings. This year's vehicle project manager, Gary Wasaya, is using a 3D modeling program called SolidWorks to improve the electric car's frame design. The frame is the backbone of the car. It protects the driver and all the other internal components, including the electronics, driver controls, suspension, and brakes. Individual tube members are drawn in as connecting lines and curves, while individual dimensions are specified according to FSAE rules, as well as to the needs of other projects on the car. Right now, Gary is working on shortening the length of the frame and simulating forces in critical members. Our second project comes from the DC Energy Storage capstone. They're using computational fluid dynamic modeling to increase airflow efficiency around our electric batteries. Here's what capstone member David Brennan has to say.
So what this simulation will actually do, or animation, will repeat a cycle of going down, then up, kind of, I guess, visualizing the vortices that are generated. As you can see, that about to cycle up from the bottom, you can see the vortices shift a bit and eventually get bigger as it moves past the midplane, and as it reaches the top midplane, it kind of disappears. This animation will showcase a much more kind of insightful view into what's actually happening to the particles. As you can see on the left-hand side, there's about 30 of these particles along a plane. One thing to also note is the vortices that I mentioned earlier at the outlet. You can see again as the particles get stuck in the middle between these standoffs, and as well as at the edges of the segment at the outlet.
Our final project comes from suspension lead Chetan Roshan, using a program called MATLAB to model how the car reacts to different forces. A force is needed to move the car forward, as well as to stop the car from moving. Using this knowledge, Chetan is able to graph the car's velocity versus time, which is shown in the green line. The selected point is the car's simulated 0 to 60 time. The red line shows the car's distance over time. So if you're interested in joining Viking Motorsports, you can visit us online at our Google sites by searching Viking Motorsports to learn more, and apply to join under our team using our Google Forms. You can also email us at psu.vms@gmail.com and visit our social media to get updates. Hope to see you at Portland State in the fall, and stay safe.